If there are any more administrative questions beyond that, please send me an email. I want to make sure everyone's clear on what's required and your expectations for this course. Okay, so to kind of start off here, so again, this is wind energy, which I think is quiz 10. Essentially, I think wind energy is really interesting, and probably after solar energy is the one that everyone is probably most familiar with, just because it's pretty easy to spot wind turbines, especially in Michigan. There seems to be, I used to work up in Alma, so I know, like, in the Alma area, I don't know if anyone's from that area, there's a ton of turbines. So I guess it's something we see all the time. So this diagram on the left here, it's just kind of showing like the basic way that a wind turbine works, or how wind energy is used to create electrical energy. So ultimately, we know that those we have wind in the air, and that blows past the turbines, which ultimately causes them to rotate. We know that when talking about energy and renewable energy, it's all about transferring different types of energy into more useful sources of energy. So kinetic energy, that is the energy that is created when the wind is pushing those turbines, because kinetic energy is moving energy in motion. So when that kinetic energy is happening, a gearbox inside that wind turbine there spins, because those turbines are spinning, which ultimately spins generator, which produces electricity. I mean, this is the most basic example, but that's basically the gist of it there. And then obviously, there's a component there that can convert that electricity to like the appropriate voltage that we'll need to run through the lines right there into the grid and get your house. So that's, I guess, the basics of how wind energy works. So I found this question on the right there interesting. So this is a question from the quiz, and I wanted to talk about it a little bit more. So the question is, why is wind turbine not 100% efficient? So why aren't we just, using these wind things all the time? Because they don't really take up that much space since they're so tall. And I think this is an important component to talk about. So that first question, A, so it cannot extract all the mechanical energy from the air. Okay, well, right away you should know that's wrong, right? Because there's no mechanical energy in the air. The air is moving, so it's kinetic energy, but it is not mechanical energy. So the second one there, it blocks the motion of air entirely. Well, that's not true, right? Because we know even with those wind energy, or with those turbines moving, there's still air going through them, right? Like that air that's passing through those blades is still going past it and still moving. So it's not just sucking the air and getting rid of it. This third one there, so air cannot pass through the blades. I think that's probably where, obviously we know that's not like the reason, I guess, that wind turbines not 100% efficient, but that last one is the one that I think is very interesting. So it cannot extract all the kinetic energy from the air. So that is the correct answer for this problem. And I think it's really, really interesting to kind of think about that concept. And it kind of makes sense if you think about it, because obviously wind is going to be constantly moving. So there's no way for us to just put a wind turbine, a million wind turbines is still not going to just take all of the wind from the air and make wind just stop. So that is the correct answer for that one. But so again, it's D, but I just think that's a really interesting question to kind of talk about and say that, it kind of ties in the fact that wind energy is ultimately created from kinetic energy. So this next little bit here is just kind of showing the inside of that turbine. As an engineer, I like little diagrams showing all the gears and all the different things, all the components inside of it. The main thing here are huge blades that we have, and I'll show a picture on the next slide that kind of shows, like the depth of how big these things are. And then obviously we have a rotor as well. So I'm going to click on this YouTube video that I found to be interesting, just to kind of play this, which might have to stop my share for a minute just so I can pull it up. Okay, so let me pull up this video.
You can stream classics like The Office whenever you like. YouTube TV.
Make any equation no problem with Chegg. Finish your semesters.
Okay.
Welcome to our.
I won't make you watch this whole thing, fair warning. So hopefully you can see the YouTube video now, but I'm only the first minute.
Short video about the components of a wind turbine.
think
Another one is Vertex are also used. But the picture now we are seeing is that horizontal axis wind turbine. Let us see the components which are being used in this construction of this wind turbine. We can see at the rear side of the wind turbine there is a thing called anemometer. So anemometer is actually
Actually, on a basis of time, I'm not gonna watch this, but that is in there if you want to. I'll send these links after. So if you want to watch that video, that's just basically going through the diagrams. So if you want to watch that, I highly suggest it because it was helpful for me. Okay, so hopefully it went back to my screen. So this is next one that I really think is interesting to talk about, and especially interesting when we're going to talk about the disadvantages and advantages of wind energy. So this is showing a size comparison for how big some of these turbines are. I mean, you can see like even these ones are well beyond like the height of a house. And I think when we see them like out in the open, it's kind of hard to actually like, or when we see them kind of so far away, like as we're driving by, it's hard to see how big they are. But in the grand scheme of things, if you were to walk right up to one, they are huge and they are loud. And that kind of goes into our advantages and disadvantages. So to talk about these for a little bit, and these are a couple of these I took directly from the quiz questions. So if you haven't taken the quiz yet on wind energy, hopefully this will help. But some of the advantages of wind energy are that it is cost effective. So once we build the wind turbines, similar to other renewable energies, it's only that initial startup of creating like the components of the wind turbines and the solar panels that are expensive. Once we get it going, it's not that expensive. So in addition, it can be built in these remote areas similar to solar energy or solar panels, and can be built on farms, on ranches. That's where we see it a lot, actually, most of the time. Also, it obviously has no pollution because it's just harnessing wind energy. And then it's minimal water use, which is a huge one, especially in a minute here when we're going to talk about hydroelectric water. When we talk about some of these other types of renewable energies, they use a huge water footprint, which is definitely not good for our environment either. Obviously, the carbon footprint, trying to reduce that is important, but reducing our water footprint is important as well. So that's a big advantage of wind energy, is that it doesn't use a lot of water. Some of the disadvantages, though, are that it does create a lot of noise pollution, which I use the word pollution there, but really it's just noise. But noise pollution is just a term for something that creates a lot of noise, which can, create harm to obviously the people living around there, but the wildlife as well. So that's kind of goes into the second one there. It's a wildlife threat. I think the biggest example of that too is like birds and even bugs and everything like that fly at that level can easily get taken out by one of those giant blades. So it needs consistent wind as well, right? So if we don't have a lot of wind, they aren't going to move and they're not going to create energy. So that doesn't help. It creates a lot of land, which that one, I guess you could argue, since it's so tall and so high up in the air, doesn't really use a lot of land, but I guess that one's kind of up to your decision if you think that's a disadvantage, or if you think it doesn't use a lot of land, you could say it is an advantage. So also the aesthetic, some people say like is a disadvantage in the sense of like having these giant turbines like in my backyard isn't something I want. Something that I do think I didn't put on the slide, but is really interesting, and I recommend if this is something you're interested about to look into it, and it's the fact that wind energy is one of the biggest renewable energy alternatives up for debate and one of the most heated ones. And I didn't talk about it too much, but the reason for that is because these things, going back to this, are so large, and probably they're only going to get bigger because the higher they are, the more energy they take, because the higher you are like in elevation or like in the sky, the faster the wind speed is. But the bigger they are here, it takes a lot of time and energy and resources to make these. And like that is kind of an argument I have, because I wouldn't say I'm for or against wind energy, but I think this is a huge component and a critical component that needs to be talked about when we're talking about the benefits of wind energy, and the benefits of it not having a water footprint or a large carbon CO2 emission footprint. The problem is like the actual creation of these and the transportation of these to these remote areas where they're most beneficial, that in itself uses a lot of gas, right, with the trucks, and it uses a lot of material that uses a lot of water and energy to create those materials. So I think that is a huge issue with wind turbines. In addition, another thing to look up if you're interested, and I can provide a resource if you want, but the other issue that they're having now with wind turbines is that when they die, what do you do with them, right? I mean, they're so big, like you can't just like stash them somewhere or put them in a landfill because of the fact that they are so big and they do have electrical components inside of them. So I do know that there are areas around the world that are in a crisis right now because of wind energy, because they have all these turbines, that once they break, what do you do with them? And that is definitely something that will probably be of concern the more we make them. I think the other thing too to think about is the amount of oil it takes to keep those things spinning adequately is another issue that some people argue for. So I just think that one, I didn't put any thing on that, but that is an interesting component of it to think. So obviously this initial startup of creating the turbines is a significant issue and one that's very interesting to look up. So the next little bit here, so on the right is that right diagram where you have the two turbines there. That is an example of a 3-blade turbine. Pretty straightforward, right? It just has 3 blades as compared to the one on the left, which has 2 turbines. I've actually never seen the one with 2 turbines or with the 2-blade turbine. I've never seen that one before, which makes sense because the 3-blade one is the one that is used more widely. And to kind of talk through why we see the one on the right a lot more, it's because it is less susceptible to failure. And that is because that one on the second there, it is hard to, that's not correct, but it's hard to that one is, sorry, oh gosh, I was thinking as I was speaking, but that one there, it doesn't balance, oh gosh, what's the opposite of, it doesn't balance well, and because it has 2 sides there, and so it is very susceptible to failing. So that's kind of why we don't use it in large scale applications. So the negative of that though is that because it only has 2 blades there, it is pretty efficient and it is really fast. So it is not great that we have to use the 3-blade ones here, but we just use them because again, it's just designed better in the sense that having 3 blades makes it less susceptible to fail because it doesn't have to worry about this balancing between the 2. Okay, so I did want to bring up this question because I think it is a very, very interesting one that they talk about here. So this question asks, what is the approximate optimum ratio of wind speed leaving a wind turbine to wind speed entering the turbine? Because obviously, we have speed or wind going into the turbine, and obviously we have speed and wind going out of the turbine. So this question here, this VO to V ratio, that is reflecting the ratio between the wind speed leaving and the wind speed entering. And then this is showing the efficiency of the rotor. So obviously, we want the highest efficiency, right? That's going to give us our optimum situation. So for this example here, you would want to look at where the peak is and then go down to see where your ratio is. And that's going to help you determine what ratio is the best for the optimal efficiency. So I just wanted to point that out because this is a question. So and kind of related to math, but not too math heavy. But again, this is just showing the efficiency, and the closer this efficiency is to 1, 1 would be 100%. So this is saying here that kind of looks like at its most optimal situation, it's going to have a 0.6 efficiency about, which is 60% efficient. Okay, so that's kind of all I wanted to really touch on wind energy. So again, this is probably the main thing here. Just know the difference between those 2 wind blades, and then also just understand the basics of how wind energy is created. So now kind of moving on to hydroelectric power. I love this diagram here. I think it's a very, very cool example in a real life situation of what hydroelectric power is. So obviously you've probably heard of that, but essentially what hydroelectric power is doing is it's harnessing potential or kinetic energy, depending on the situation, which ultimately means they're flowing water into a turbine by the powers of gravity. And once it creates that turbine to spin, that ultimately is used to generate electricity, just like all other generators. So I think this is kind of a similar trend. If you haven't kind of caught on yet, it's that typically all of these renewable energy sources are somehow using a renewable situation of like movement, right? So like wind energy or solar energy, which is movement at the molecular level, or hydroelectric power, which is the movement of water, to ultimately create mechanical energy or this turning of a turbine, which then creates which ultimately can be converted to electrical energy and all of that. So I think it's kind of important too, I didn't mention it, but going back to wind energy, something I didn't mention. So this idea of windmills we've used for years, right? Like, back in hundreds of years ago when they used those windmills to power and, like for like grain applications and everything like that, they just didn't harness electricity, but they still used it for like mechanical to convert that wind energy to mechanical energy. So it was kind of a similar situation that windmills, even though windmills aren't turbines and don't look like this, it's still the similar application of their moving this blade to ultimately benefit society. So, okay, where was I? I was here. So I did put this in too. I do think this is an interesting one I wanted to pull up. So let me pull this one up. Share for a minute. Okay, so what I'm going to pull up right now is a really basic video. It's only 3 minutes long that shows hydropower and how it's used. And I think watching this video is very beneficial. So I want to play this.
Hydropower, or hydroelectricity, refers to the conversion of energy from flowing water into electricity. It is considered a renewable energy source because the water cycle is constantly renewed by the sun. One of the first uses of hydro energy was for mechanical milling, such as grinding grains. But today, modern hydro plants produce electricity using turbines and generators.
So you can see, kind of going back to that first example, like, let's see if I can rewind it for a minute. Like this example, like kind of going back to it's the same, the same principle for windmills, obviously as these for milling grain, but they still have that huge rotator that is ultimately doing the same thing that hydroelectric power is doing, in the sense that it is using or converting it to mechanical energy. But for our most modern applications, we're taking it a step further and taking the mechanical energy and converting it to electrical energy, which is hydroelectric power.
Modern hydro plants produce electricity using turbines and generators. Mechanical energy created by moving water spins rotors on a turbine. This turbine is connected to an electromagnetic generator, which produces electricity when the turbine spins. There are 2 main types of hydroelectricity production: dams and run-of-river. Hydro dams utilize the potential energy from damped water to produce electricity. A dam is a large barrier constructed to raise the level of water and control its flow. The elevation created by the dam creates gravitational force for turning the turbine when water is released.
So that's how I mentioned a minute ago, like by the flow of gravity, that water moves down. So that's the point of like the dam in this situation, is it's basically damming the water there to create a high reservoir at top. And that water only has that small little pathway to flow down, which is how essentially they are creating a continual flow of energy, because this water is slowly flowing down into this turbine, which is creating it, making it spin, which ultimately is running our generator, which is then hooked up to a transformer to convert the electricity to our most useful form, or convert the energy to our most useful form, which can power our electric grid. So that's really the main idea there. But I definitely think the rest of this video is pretty interesting, but I will stop there in the interest of time. But I just wanted to play this to, again, I like the visuals. So, okay. To kind of move on, this is very interesting to talk about the advantages and disadvantages of hydroelectric power. So kind of similar to wind energy, I think that the advantages kind of go into the fact that it is constant, right? You know, this constant flow of water is always going to be continually moving and always causing that turbine to spin because of the fact that this dam is only allowing a express amount of water at a time. So that's kind of how it's functioning. So it's also a clean fuel source, right? It's just using water. There's nothing wrong about using water. There's no energy issues with using water. It's not going to cause pollution. So that's a benefit. It's pretty inexpensive, right? Because again, this is just moving by the natural flow of gravity. So there's nothing there's no like cost that they're going to have to put into this. I also think too, like looking at like solar panels, there are issues with those in the sense that they can have maintenance issues, right? Like solar panels and wind turbines might have maintenance issues that need to be fixed because of all like the electrical components inside. I think that's probably not as likely with hydroelectric power. So a few of the disadvantages here. So some of the ones the book talks about are the fact that it can ruin vegetation just because you are manipulating where that natural flow of the water is supposed to go by creating the dam. Likewise, that can impact fish mobility because the fish might be stuck in the dam or at the bottom of the dam and can't flow to wherever they or swim to wherever they want to. Wildlife changes kind of, you know, if the fish are stuck in one spot, that means that the animals that eat the fish might not have fish to eat, depending on where they are located throughout the dam. I think the other huge significant threat to hydroelectric power is if those dams break, right? Because all of the houses that sit below the dam could be subject to significant flooding or even death by just the impact and sheer force of that water coming down. Obviously, the upfront costs of creating the hydroelectric dam. But I think this biggest one here I have in all caps is cement. So when talking about sustainability, cement is something that is very significant to impacting the very significant factor that's impacting the environment. And it's not heavily talked about a lot, but I did provide these two resources. And I really think if this one here, I think is a little more like, not as like, it's a more opinion-based one, so it's not as factual, I guess, but it's definitely like an interesting one to kind of read and give your opinions on it if you agree, if you disagree, because it definitely talks about like the destructiveness and like the environmental catastrophes that can happen because of cement or concrete. And the reason I'm talking about cement and concrete is because, as you can see this, I mean, creating this dam is essentially all concrete and it uses a lot of it. So this is the last video I'm going to play for you, but it is really, this one is very interesting, I think. So hopefully it keeps your attention. So I've taken a lot of sustainability courses, and it seems like all of them always go back to talking about cement, and that's the issue, which is interesting because like it seems like in the media and everything, I only hear about like plastic being a issue and the fact that plastic is not breaking down, but what no one talks about is that cement's not breaking down either. And we don't see cement like we see plastic, you know, like how we see like microplastics in fish and in our bodies and everything like that. We don't see cement in our bodies because of the fact that cement doesn't break down, which that in itself is a concern for the future, right? That it just doesn't break down. So again, this video just is kind of showing the significant impacts of concrete / cement. And again, the reason that this is related to hydroelectric power is because hydroelectric power is created with dams, and dams are created by large amounts of concrete. All right.
Welcome to Civil Mentor. This video is all about the adverse effects of concrete.
I apologize the noise, it's the Siri voice, but
I would like you to subscribe us and press the bell icon so that you never miss an update. Growing concerns about the environment climate change in particular have highlighted another major problem with concrete. After transportation and energy, cement production is the third biggest source of carbon dioxide emissions.
So I think this, I'm going to pause here because this is a huge thing to kind of take in and grasp. So what they're saying, cement, and again, I apologize, it's hard to kind of hear, it's a little quiet. I hate the recording voices. I wish it was like a real person talking. But so essentially what this is saying, that cement production, so the actual process of creating cement, is the third biggest source of carbon dioxide emissions, which is a huge number if you think about it. So just like the fact that the energy processes and the chemical processes that have to take place in order for cement to be created is a significant source of CO2 emissions.
That's partly because the process of making cement releases a lot of carbon dioxide, but also, very importantly, because of the enormous amount of cement and concrete used worldwide. The carbon dioxide is released in two quite different ways. First, because of the fossil fuel energy used during the manufacture of cement. Second, because cement is produced when calcium carbonate turns to calcium oxide, releasing carbon dioxide in the process. Concrete relies on cement, so it's anything but a sustainable material, which worries engineers in particular because they tend to be very environmentally conscious. Since carbon dioxide is released in two ways during cement production, it follows that there are two ways of making more environmentally friendly concrete. Historically, since the Industrial Revolution, much of humankind's energy has come from burning coal.
Okay, I'm going to stop this video here and move back to our slides, but I'll send you this too if you want to watch the rest of any of these videos I post. But again, I just am adding this because I think this is a really interesting concept to talk about. We could have a whole class in fact, there are whole classes on cement and the vast components that come into play with talking about cement and the production of cement and the aftermath of cement, how it virtually is here forever. So yeah, I just think that's a really interesting component. And I also think talking about these disadvantages, I hope I'm not making you think that all of these renewable energy sources are never going to work, because hopefully they will one day be able to replace from the burning of fossil fuels and how we're creating energy now. But I think it's important to look at the disadvantages and see what's not working in order to modify and change and design new renewable energy sources that don't have those disadvantages. So, for hydroelectric power, developing a similar type of situation that doesn't use so much concrete to dam the water would be a significant way to reduce that aspect of the disadvantage. So this little side here, this is also given in the as one of the quiz questions, and I wanted to talk about it because it's a little bit nitpicky, and you might get it wrong just by if you're not estimating correctly. So I'm just going to kind of talk about what this is showing here. So ultimately, here is if you've never seen one of these graphs before, when talking about in sustainable applications, these types of graphs are used a lot. These are my favorite actually, because I think they show visually a visual representation of actually what is going on. So what this is showing is that this is given a time period in Canada. So from 1975 to 2020, it's showing all of the energy sources. So coal, fossil fuel, right? Gas, oil, all of these are fossil fuels, which makes sense how we can see that, those are significant portions. And then it's showing all other renewable sources that we talked about. So wind, hydro, solar, nuclear, which we haven't talked about too much, or we probably won't talk about in an interest of time in this course, but ultimately it's just showing all the different ways to create energy or harness energy. And so what it's showing is the percent of percent of each component here that is proportions, I guess they're using it. So for example, this whole blue section here is showing that in 1975, 200 TWh was so like a big majority, I guess, of their energy production was by hydro. And then all of these are showing, I guess, like over time, like how their usage is changing, or like how their different sources is changing, I guess, too. So like you can see that all in all of them are increasing, which makes sense because we're having more population, we've got to use more energy. And then obviously this is showing like how some of them are having like peaks up and down where maybe they're not being as beneficial. So I think this one says like, what is the ratio of hydro energy in 1975 as compared to all of the rest of the types of energy sources? So for that one, you would have to go to 1975 and see that it's at about 200, right? And then you'd see that in total, all of these combined is at about 300, right? So in order to find the ratio or the percent that is hydro, you would just do 200 divided by 300. And again, that's just going to give you a percentage of like how much hydroelectric energy they're using. So this is all this diagram is showing. Again, it's just showing the different proportions of electricity that Canada is using throughout time. It's showing how that is changing. And then it's also giving us a lot of valuable information to see like what the biggest proponent is. So obviously like 200 divided by 300 is like 66 or 70. I think if you estimated it correctly, it might be a little higher than that, but it's showing like 60% is in hydroelectric, which is a pretty significant portion. So I think this diagram is very beneficial for that reason. But if you have questions on this quiz, feel free to send me an email, because I think it's pretty straightforward. It's just you have to be really picky with your estimizations. So make sure you eyeball it very closely, because like I said, like I think they also want you to look at like 2005, and like I was doing it really fast. I was like, okay, that's at like 400, and then like my percentages were way off. So you could get a ruler if you really want your answers to be correct, but yeah. Okay, so that's kind of it for hydroelectric power. I think that one diagram really shows the most like the critical pieces of it. So again, and also this is a major component of it too, just know the advantages and the disadvantages. So for wave energy, I know we only have like 9 more minutes, so I'm not going to talk too much about wave energy, but I will say I'm going to go on to this slide. So I only have 2 more slides. So I do want to watch one of these videos, because one of them shows this picture, which I don't know if I grabbed that from the book, but there's probably a similar picture of this in the book. And I think I don't really think the book does a great job of explaining wave energy. At least reading it through was kind of like, well, they're not really covering all the components. So I'll probably talk about wave energy next week as well. But I do think this video that I found was very helpful. So I am going to watch this. So this again is just another short one. I like the short videos if you haven't noticed. I don't have a long attention span, so. Okay, so let me share my screen and we will watch how wind energy works. So this is a really short video, so. And there's no sound. Okay, I'm pausing here because this is important. So first up here, so we all know what waves are, but waves are created by the wind, which is in turn caused by the sun. That's the sentence, and that is a quiz question, I believe, where it talks about, or a quiz answer talks about like how wind energy is ultimately manifested by solar energy, and it is. And the reason for that is because waves are created essentially because of wind, right? The wind is causing the peaks in the waves. And wind is caused by solar energy, or the thermal stratification, because obviously I'm trying to think how to explain it best, but the reason that there's wind is because there's different temperatures of different like heights in the sky, right? And so it creates a gradient because the different temperatures have different densities, right? And so density directly impacts, I guess, the different levels, and then it's causing it to kind of swirl around. So I know that probably was confusing, but the main idea here is that solar energy or heat is creating different temperatures, which is ultimately creating different densities in the sky, which creates the stratification layer, which is creating wind, and that wind is used or is creating waves. So this little yellow thing bobbing is the device that was shown in that picture. So as that surface is, of the water is moving, obviously so is that device. And then it's showing us that underneath here, we have a magnet, and that magnet is moving along. It's rotating along with that up and down movement. So, and then obviously there's some electrical components in play here, and that's connected right to the ground or the surface of the floor. And then those cables are connected under the surface. Obviously, this is in series, right? We just having one wouldn't give us enough energy. And then ultimately that, it doesn't show the rest of that there, but that cable goes onto shore, onto some plant or some type of facility that is able to harness it better and use it for electrical applications. So I thought that video was interesting, and I think it was, you know, it's, I feel bad talking this whole time, so I think it's nice to show some visuals there. So to kind of go back, gosh, we're running out of time. To go back here, this video I put in here just because it's a really interesting one that kind of talks about how wind energy is really great. We're just not there yet. And ultimately it's all just because of a lot of different reasons, but really like it doesn't harness enough energy for us yet. But it definitely is an interesting video to watch. So if you want some more information on that, look at that. So last little bit here. So some important concepts when talking about wave energy to kind of remember. So that first one there, wave energy is basically a manifestation of solar energy. I know I probably confused you a minute ago, but really just know that it's kind of like a chain. We go from solar energy to wind energy to wave energy. All of them are interconnected. So waves occur everywhere in the ocean. You know, that's kind of why it is beneficial. So there are waves everywhere, but the issue is some locations, going on to that third bullet point, some locations on Earth do have larger waves than others, and all of that is related to the fact that there's different temperatures around the world, and all of that goes back to the fact that because there's different temperatures, there's different speeds of wind or different components of the wind that is ultimately causing some areas to have higher or larger waves. So, which we know that, right? Because places like Hawaii have huge winds and huge waves. So ocean waves are primarily the result of the interaction between the wind and the sea. So that one's pretty straightforward, right? But same thing here. So all this is just showing that solar energy, wind energy, and wave energy are all very much related. They just are, we're harnessing the energy at different steps along this natural processes of Earth to create electrical energy to ultimately use that to have electricity in our homes. So, okay, I know we're running out of time, so I will, if you want, I can send this to you all. It has all of the links kind of embedded. You can copy and paste them to watch some of these videos or read some of these articles on if you're interested. And then going forward next week, I will probably talk about quiz 13 and 14. So those are parts of week 5. And then bring any questions you have, if you want to bring any of your like conceptual questions, and then if you have any concerns with the math questions, let me know and I can knock off a few points. If a few of those math questions happen to secretly get their way into the next couple of quizzes, just let me know and I'll adjust that for you. So with that, are there any other questions?
No, I'm good.
Okay, well, thanks for coming.
All right, thank you.
Yeah, thanks. Hi, Corey, any questions?